Compressor blades are key components in a jet's engine. The heart of the turbo machine contains thousands of them. They rotate 400 times per second, whipping air into small hurricanes. They compress the air, making it so hot and so dense that it literally explodes when mixed with fuel in the combustion chamber. In a jet engine, large compressor blades made of titanium compress the air entering the front of the turbo chamber. They move the air towards the back of the chamber, where smaller blades made of a nickel alloy compress it even more. The air heats up to more than 600 degrees Celsius, then combines with jet fuel, creating a powerful mix that explodes out the back of the engine. The blades start off as metal pellets called slugs. A ceramic layer prevents their surface from oxidizing when exposed to intense heat. The slugs are heated for 15 minutes in a 980 degrees Celsius oven. Meanwhile, a robot sprays lubricant on two forming dies inside a press. The robot retrieves the slugs and loads them in the first die. The press applies 1,000 metric tons of pressure to preform the metal. The robot then transfers the slugs to the second die, where they take the initial shape of the blade. The blades are then dipped in water to cool. The next robot cleans the metal burrs off the edges. The blade is now an airfoil. Robots will shape the rounded base, called the dovetail, later. The airfoil has gone from this to this. After a new ceramic layer is applied, the blade is once again heated in a convection oven to 980 degrees Celsius. Each heating and cooling cycle tempers the metal, making it more resilient. 1,600 metric tons of pressure gives the airfoil its final shape. A trimmer shaves off the excess metal. The heat turned the protective ceramic layer into glass. It'll come off later. It's taken an hour to shape the blade's airfoil. The dovetail, that nub on the right, is next. But first, this measuring machine inspects the airfoil. If any measurement is off by just half the thickness of a human hair, the blade doesn't make the cut. This casting machine will encase the airfoil in a matrix, a coating that protects the airfoil during work on the dovetail. They mold the matrix from liquid tin and bismuth. It solidifies into a metal cast around the airfoil. The future dovetail sticks out at the end. They load the cast into what's called a broach machine, with a series of teeth that carve the dovetail to its final shape. Now the cast can come off. A worker loads it onto the removal machine. A hydraulic cylinder hits the cast at its weakest point, breaking it in half. The finished airfoil emerges unscathed. A dot matrix machine punches identification numbers onto the blade. Next, they submerge the blades in fluid that penetrates any flaws in the metal. This inspection is critical because even the tiniest nick can spell disaster when a jet's engines work at full speed. They examine the blades under a black light. This blade is perfect. But spots of fluorescence on this one indicate microscopic cracks and weaknesses. This one gets rejected. The dovetail gets 2 strips of rubber silicone that ensure an airtight seal when the dovetail slides into its slot on the compressor drum. A final check, and the blades are now ready for takeoff.